Hello everyone. Today I'm taking a look at Proxmox, but not Proxmox VE. I'm taking a look at Proxmox Backup Server. So ever since Proxmox's biggest competitor was acquired, I've seen a lot of talk from people who are trying to migrate to Proxmox for the first time, and they're trying to apply the same design standards and principles they've used with other systems with Proxmox. And in the case of Proxmox VE, that's probably not that far from how it is in reality. But for Proxmox Backup Server, the architecture is very different for something like Veeam. So, to dispel some of those myths, I'm making this video to talk about the architecture of Proxmox Backup Server, how it stores and deduplicates your data, and more. So if Proxmox Backup Server is something you're thinking about deploying, then come along on this adventure. But first, this video is sponsored by Ugreen and their NAS Sync series. Now the model I'm using today is a DXP 4800 Plus. This is their mid-tier unit with 4 hard drive bays and 2 M.2 NVMe bays. Now this model has 10 gigabit Ethernet, which is great for a high-speed backup server like this, but all of Ugreen's models feature at least 2.5 gigabit Ethernet standard, so there's no upcharge for high-speed networking. Now I'm filling this guy with Western Digital Red NAS hard drives, but you can use whatever drive models you want. Ugreen does not restrict you at all in their operating system. Now speaking of Ugreen OS, it comes pre-installed on these guys, and it's got some out-of-the-box file sharing and multimedia sharing kind of apps, but you can also run Docker apps natively on Ugreen OS and virtual machines as well for full expansion. But of course, this thing is also just running an Intel processor, so we can run whatever software we want on it. Ugreen doesn't restrict us there either. So I'm going to install Proxmox Backup Server directly on this guy today, but if you want to, you could also install it through Docker as well. There's some unofficial Docker containers for PBS. So don't forget to check out Ugreen's whole NAS Sync series at the link in the description below. If you hurry, you can get up to 25% off in the Prime Summer Sale. Now back to the video. So, what is the architecture of Proxmox Backup Server after all? Let's come take a look with some diagrams. So maybe I need like a little sidebar for visualizations or something. So in Proxmox Backup Server, we really have 2 different types of nodes, just 2. We have the server that runs Proxmox Backup Server, obviously. That is a software that runs on Linux. It generally runs on Debian if you install it from their packages, but it doesn't have to. It's written in Rust. Unlike Proxmox VE, it's not that picky about the environment it runs in. The other side of this is the client. So this is Proxmox Backup Client, also written in Rust. They provide packages for it for Debian and Ubuntu-based systems. I've seen people compile it for ARM. I've run it on Raspberry Pi myself. There's a Docker image available, etc. This is also included in Proxmox VE. So any system we are actually backing up runs the client. Or the client is running in our hypervisor to back up the virtual machine, one of those 2. Now the first and most critical thing to understand about this is that unlike some other backup systems, Proxmox backups are always push-based. This means that the client decides when it is time to do a backup. Then it sends that backup to the server for storage. The server is not involved in the timing of when to take a backup. It is just involved in how long to save that backup once it's been done. So, you won't be going to Proxmox Backup Server to edit your backup schedule. You will be going there to edit like your prune schedules, how long you're going to retain those backups, how often you're going to verify their checksums. That is done in Proxmox Backup Server. But the actual taking of the backups is entirely on the client. Now if you run Proxmox VE as your hypervisor, then that is where you'll find this information. Proxmox VE has a well-established backup system. It's been in Proxmox for a long time, and that is extended to support PBS as well. You add PBS as a data store. Super easy to schedule timed backups of certain VMs, all VMs, excluding some, etc. And that's how you're normally going to configure this. However, we're not restricted to just Proxmox VE. We are more than welcome to run the backup client on any Linux system. And I've run this on Raspberry Pis, I run this on VPSs in the cloud. All you need is a simple systemd script or a cron job to call the backup client and do a backup. I have those available on my link on my website if you're interested in those. Now another thing that's important to consider is that all backups in Proxmox Backup System are considered to be full backups. They contain a full list of all data on the system at the time the backup was taken. So we're not doing anything incremental. We never have to merge or coalesce different backups. We can delete any backup at will. we rely on deduplication to filter out the excess data instead of doing incremental backups. Now there are some tricks to this that make it act more like an incremental backup. However, a given backup on the backup server always has a full snapshot of the file system or the block device at that point in time. Now the last architecture question I've seen some people stumbling over is they want to add some sort of cache, some sort of proxy. They have multiple data centers and multiple cloud locations. They don't want to send so much data between them. So there is not exactly a node that does that in the Proxmox backup system. However, every single Proxmox backup server is capable of replicating backups to any other Proxmox backup server. And this can be either pushed or pulled when you're doing replication between two nodes. So there's nothing stopping you from creating a backup server at each location site, doing regular, frequent backups there, and then doing nightly syncs off-site, for example, where you might have your tape drive in a central location, something like that. That is how the architecture is intended to work. We don't need a separate sort of slave node because every backup server can act independently, can replicate to each other. So, theory is great and all, but at this point we probably need a working Proxmox backup system to play with. So let's set that up. So for that, I've got my Proxmox branded flash drive. You can use whatever flash drive you want. And I have imaged this with the ISO. We're going to get started. So I am now hanging out in the BIOS, and I have to do a little bit of changes here first. Oh, by the way, BIOS on this guy, Control F2, get into the BIOS. So this guy has a watchdog, which is fantastic, but we're going to want to turn the watchdog off, at least while we're installing software. So I'll go ahead and disable that for now. And then I'm going to change my boot device to be my UEFI USB hard disk, and we'll save and exit. I am really glad Ugreen has a watchdog on their systems. A lot of smaller NAS systems don't have watchdog ASICs, so this is sort of a more enterprise-like feature. So then when I get here to the install screen, I can choose graphical, terminal, etc. I'm just going to go with graphical. So first up, I've got the option to choose what hard drive I want. In this case, I'm going on the internal drive, NVMe 0 and 1. This is the one that's built into the Ugreen. We have the option to choose ext4 or ZFS. I'm going to choose ZFS because we always want ZFS pretty much. So future Apple Art here, when you pick a ZFS, it defaults to installing it across every single drive in the system. Now you're more than welcome to install the system on the data drives. Proxmox has absolutely no problem with that. It's not a problem at all. However, I'm using the 128 gig boot drive on the Ugreen. I made the mistake of installing it on my data drives as well and regretted that, so don't be like me. Also, my next button has disappeared, so I'll just have to tab over to it. Here in the D, I need a password. I'm going to choose the 10 gig card, it's the Atlantic driver, and I need to give it a host name and an IP address. And we're off. So at this point, I've got Proxmox Backup installing itself onto the operating system drive. This Ugreen comes with a 128 gig SSD that I'm using for this purpose. There's two M.2 slots available if you want to use something else. I'm using ZFS on a single disk because we should always use ZFS on bare metal. Once this guy gets installed and booted up, I'm going to log in and create the ZFS pool, and we'll work through that. So over here, I'm logged into Proxmox Backup Server. First thing I got to do is add my disks. So I come down to the sidebar, click on Storage Disks. So here I've got my 4 disks, A, B, C, and D. These are my 4 terabyte drives. And I've also got my boot drive, NVMe 0 and 1. I come over here to the ZFS tab and create ZFS. So now I have the option to choose any or all of these 4 disks. I can use A shift as 12. RAID level I'm going to use is RAID Z, so that's equivalent to RAID 5. And we're going to call this backup. And then if we check add as data store, it'll automatically do everything we need to add it as a data store. Nice and easy. So after that's finished now, I have rpool, which is my boot drive in ZFS, and I have backup, which says 15 terabytes free. And I come here to backup, and I see I've got 11 terabytes usable, 11.5 terabytes usable with RAID Z, and I'm ready to go. So before we get too far along, I think it's important to understand how Proxmox deduplicates our data. Now the classic problem with any backup system is how do we avoid spending like 10 times as much disk space on backups than we had for the original data. If we keep 10 copies, naively our backups should be 10 times as big. But with Proxmox Backup Server, they're not. So what is Proxmox Backup Server doing to incrementalize or compress our data? So imagine I have a hypothetical virtual machine I'm trying to back up. And this VM, we'll say, has a 100 gigabyte disk. Now, it's pretty much like a fresh install of Windows Server, isn't it? So you feel me, right? So now let's say I want to keep 10 backups. I got 7 dailies, a 1 month, a 3 month, a 1 year. That would add up to 1,000 gigabytes of data, right? If I just do the naive approach of taking an image of my virtual machine disk every time I take a backup, I have my 100 gig virtual machine disk, I have 10 backups, so 1 terabyte of space wasted on backups. Of course, backups aren't really wasted, but I probably could do something to compress that space down a lot. And there are a number of different techniques Proxmox uses to reduce the amount of space we need to keep so many backups. Now, one approach taken by a lot of competing backup solutions is called incremental backups. So every time we take a backup, we look at all of the data on disk and we decide if it's different from our last backup. And we only store the differences. Now, this makes a lot of sense. If we have a 100 gig VM, there's a good chance like half of those files are DLLs anyway that aren't going to change, right? So we're saving space each time because we're only changing the differences. However, now we have a bunch of files in our backup system that depend on each other. So if we want to delete a backup or the backup expires, we have to coagulate these incremental backups and figure out what differences there were between them and move our baseline forward. And that takes time, computational effort, reading backup data if we don't have good metadata. So that's not an approach Proxmox Backup Server takes, but it is an approach many competing solutions take, and that's why I'm mentioning it here. So all of the deduplication and space savings used by Proxmox Backup Server all revolve around chunks. So every time we take a backup of a machine, whether it's a virtual machine or a physical machine, we split that backup into chunks. And these chunks are 4 megabytes. That's not that big, but it's also not as small as like a single block on a hard disk. Every time we take one of these chunks, we take the hash, we're using SHA-256, of that block of data and use that hash as the name of the chunk. So now we've taken 4 megabytes of data, which is real data, and condensed it down to an identifier that is 256 bits long, SHA-256. So now, when Proxmox takes a backup, instead of storing all 100 gigs or however much we have for the VM disk in the backup file, we just store a list of all the chunks. So these chunks are not that big. We identify them as their 256-bit hash. So a backup manifest for a virtual machine would just be the list of chunks, one after another. So we divide the size of the VM by 4 megabytes. That's how long the manifest is. Every single backup in Proxmox Backup Server will have a complete manifest. So they're not incremental. They always list all of the chunks that are part of that backup in order. So if we were to have access to those chunks and the manifest, we can recreate the exact block volume of the device by reorganizing these chunks in the order the manifest tells us. Then separately, we store the actual data for the chunks. So this is shared between an entire data store in PBS. So if you have multiple servers, multiple backups for the same server, multiple servers running the same operating system, multiple servers running a different operating system, all of them are sharing the same big folder full of chunks. And in fact, it'll create 65,000 folders in that folder, etc. So there will be probably millions of files in your chunk folder, and those are all going to be 4 megabyte chunks. So when we want to replicate a backup, we have to figure out what chunks are part of that backup, pull them off the file system, pull the manifest with it, and that is how we end up with a backup. Now, this chunk-based approach gives us several advantages. In fact, there's 3 different parts of the process where we can do optimization shortcuts to reduce the amount of work we have to do to get a complete backup. So the first shortcut we have is for virtual machines that are still running in Proxmox VE, we can track what data has changed. So Proxmox virtualization environment, Proxmox VE, can track which 4 megabyte chunks have been accessed by the virtual machine. It does this using QEMU. So then Proxmox Backup Server knows it doesn't have to check those chunks. It can read the chunk manifest from the previous backup and then include that into the new backup. So we're not pointing to the previous backup, we're copying the chunk list from the previous backup into the new backup where QEMU said we didn't have to read the data. The second place for optimization is if chunks are the same. So very often large parts of the hard drive will be blank. They'll be all zeros. So all zeros will have the same hash, and we won't have to send the same chunk twice because it's the same. Since the SHA-256 hash is the same, the data is the same, if we have 2 chunks that are the same, we just include that twice in the manifest, and we don't send the data more than once. So with this approach, if your VM disks are partially empty, we're not sending the extra space, even without compression. We do compression as well, but even without compression, we're still getting that savings. Now when doing this, sending data to the server, Proxmox Backup has to send both of the chunks from the backup and the manifest. But it will read the previous manifest to know what chunks are already on the server. So the server will already have many chunks that are the same as a past backup, so we don't have to send them over the network. We still might send them over the network if they're damaged or something on the server, but we don't have to send all of the data over the network if we know what's already on the server. And the last approach is server-side. So the server will only keep one copy of each chunk. It can use SHA-256 to verify that the chunks are accurate, so we don't have to use a file system like ZFS, although ZFS provides a lot of advantages anyway. Proxmox Backup Server can run through and verify all the chunks are correct, but also, if one backup tries to send a chunk and that chunk already exists on a backup server, possibly from a different backup, it knows it doesn't have to store that new chunk because the data is the same as the old chunk. So these 3 levels of deduplication lead to quite a lot of savings. We're saving reading from the VM disk if the VM hasn't shut down. We're saving on network traffic for data that hasn't changed since the last backup. We're saving on disk space on the backup server across multiple backups of the same VM and multiple backups of different VMs if their contents are the same. And we're doing all of this without pointing backups to each other. So a given backup manifest contains the complete listing of all of the chunks that exist in a backup. So to delete a backup, all we have to do is delete the manifest. Periodically then we run a prune job, which accumulates what chunks are in use by any backup on the server and deletes extra chunks. We can also do a verify job, which runs through and checks that all the chunks have good data integrity. Now, for file-based backups, there's a little bit of an extra step here. So file-based backups store the file's metadata separately from the file's data. And this means we don't have to read the contents of every single file if we're doing a file-based backup. We compare metadata to metadata, see if it's different, and then if it is different, we have to back up that whole file, or at least read in the whole file to see what parts of the file have changed. For file-based backup, we also use a dynamic-based chunk that's not exactly 4 megabytes, but the difference isn't super important here. So, now that we understand how dedub works, let's actually do some backups and restores with some clients. So I'm back down here in the lab now. I got my Proxmox Backup Server we've been setting up for this video. That guy there in the cardboard box runs Proxmox VE, the hypervisor, so we can test backing up virtual machines and containers. This guy is a bare metal system, so we can test imaging bare metal systems, and we can also test imaging Linux systems through Proxmox Backup Server. So Proxmox Backup Server supports both block-based devices such as virtual machine disks and physical real disks, so we can back up that way. It also supports file system backup on Linux. So we can back up Linux containers that way in Proxmox VE, and if we have a bare metal Linux system, or say like a Linux cloud system on a public cloud, we can back that up through the Proxmox Backup client running on Linux. So let's take a look at all those options now. So over here in the backup server, it's doing literally nothing. And if I look at the backup, look at the contents, it's got no backups on it. So let's fix that. So coming back over here to my Proxmox virtual environment, let's go to Data Center Storage. I already have one Proxmox Backup Server, so let's add another one here. Type Proxmox Backup Server. So the name we give it is just relevant in Proxmox VE. I gave it the DNS name of the server, and now we need a username and password. So back over here in the backup server, let's go ahead and create an account for Proxmox VE to use. So I'm going to add a new user. We're going to call him lab user. He's going to be part of Proxmox Backup Authentication Server, and we could have generate a random password there. I'm never going to use this password, so it doesn't really matter. So next up, I'm going to create an API token from lab user. So we'll come over here and we'll say add token. The user is going to be lab user. The token name is going to be Prox VE, and we'll go ahead and add that. So now it gave me a username and a secret. So I can copy this username over here into Proxmox, and I can copy this secret. So now I've copied my username, which is my API token, and my secret. So then I can enable it. We can use it on all nodes. I only have one node anyway. My data store name is called backup. My namespace is root. I'll get into namespaces later. And last thing I need is the fingerprint of the certificate. So coming back over here, we go to the dashboard and we say show fingerprint, and we copy, and we can paste that guy in here. So before I get too far ahead, I need to give this API token here some permissions. So I hit show permissions, he has none. So if I go here to permissions, I can add API token permission, and we want to give him the ability to data store backup to that guy. And his role would be database backup. So let's go ahead and add that. So in addition to doing that for the API token, we also have to do it for the user itself, since the API token is restricted to the permissions of its parent user. So I did that here. Now they both have data store backup role on our backup data store. So now finally I can click add over here, and there we go, we're good. So now that we have our data store added, I can go hit backup here. I could add a scheduled backup, or I can go to any one of my virtual machines and just back it up right now. So let's pick one. Which guy do we want to back up? We'll back this guy up. So I'll say backup now. We're going to back him up to Prox Backup, and let's go. So over here on the server, we can see under tasks, it's got a backup of VM 549. And if I take a look at what's going on, it'll show me what's going on. Okay, so Proxmox said it finished, task OK. Let's go back to the server. So here on the server, I go to my data store, I go to contents. I can see I've got a new backup named VM 549. I open it. Here's one specific backup for that entity, and it has some files under it. These are the backup manifest. So drive SCSI0.image, that's my SCSI disk from the VM. I can download the whole thing if I want. Some other files are stored as well. So this is the Proxmox configuration file to restore that, and other metadata about the backup. So at this point now, it says it's only using 4.3 gigs, even though I just backed up 64 gigs here. So that's a combination of the backup being sparse, mostly zeros, and compression. So I come back here and I run the backup again, just to see what that does. We'll run it again. And that was fast. 5 seconds. So now I've got two VMs here. They both are complete looking backups. They're both 64 gigs. I can delete either one of them without any problems. But if I go to my summary, I'm still only using 4.31 gigabytes. So that extra backup that I took back to back only added 10 megabytes to my data on disk. Now I'm sure most of you guys that are migrating from some other virtualization platform that got eaten to Proxmox's environment are probably thinking about virtual machines. But Proxmox VE also supports another option, and that is Linux containers. So Linux LXC containers are not the same thing as Docker containers. These are like a host level container. So we have a full Linux environment that we can SSH into. It has its own network stack, its own IP address, etc. But it's running in a container instead of in a separate VM kernel. So Proxmox supports those as well, and we can back those up, and the backup process is a little bit different. So let's say I want to back up this container, so I'll go hit backup now. Now I'm again going to pick Prox Backup. But now I have a new option here, PBS change detection mode, so default data or metadata. And this changes if it should save the metadata separately. We're going to pick metadata. So whether or not metadata is more efficient for you depends a bit on how big your files are. So in data mode, Proxmox will read all of the files off the file system, concatenate them together, sort of like a tar file, and run a rolling hash over that. And periodically it will chunk that data stream. So using data change detection mode means it has to read every single file from disk. Now, this sounds not great, but the other option is metadata mode. So with metadata mode, it stores all the metadata for files separately in the backup. Now this means our metadata is not part of our chunk system, so it's not deduplicated. So if you have a huge number of files on your VM, it's possible that metadata size will actually take up quite a bit of real space. You'll have a worse deduplication ratio. But for most people, especially if you're storing like backing up like your big backup server, like your file server, I like using metadata mode. So I use metadata mode on my video server. I have a bunch of video files, they're huge. And for me that works really well. Of course your mileage may vary, but that's what I do. And there we go, we're done with that. So now I've got my VM and my container. So look at my container backup. This is a little bit different. So we have an mpixar and a ppixar. This is our metadata versus our data. And if I click on this one, I can actually look at the contents of this system. This is a Linux system, so obviously it has etc, it has files in here. If I pick one of these files at random, I don't know, like etc group, Etsy shadow, which one's your favorite? Host name, we'll pick Etsy host name. I can download that file here, and whoop, there we go. So not very exciting, but that's the contents of the file. Now while I expect most of you guys that run Proxmox Backup Server will be using Proxmox Virtualization Environment, the hypervisor, as well, that's not required. You can use Proxmox Backup Client to back up physical disks or block devices, as well as the whole file system of any Linux-based machine. Now the client is limited to only running on Linux currently, but it's not specific to any distro. So it comes pre-compiled for Debian and Ubuntu, and there are some third-party projects that are publishing packages for like Fedora, Red Hat, as well as Raspberry Pi, and I've used all of those myself and they work very well. So let's see what it looks like to run the client to back up a Linux server from within the server. So I'm here on a real server. I mean, it's not a virtual machine or anything, but it's a real server, we'll pretend. And so I need to install the client. So here I'm at the Proxmox Backup installation page, and this is where we can get the client. So let's scroll down on the sidebar here, I can say client installation. So they have two different versions available here. So they have the apt-based repository, and they have a statically linked build that can run on any x86-64 system. So I'm using the app-based approach. They have a repository just for the client for Bookworm, Bullseye, Buster. So go ahead and add this to my sources.list here. Okay, so I'm going to do apt update, then I'm going to tell it to upgrade packages, and then install Proxmox Backup Client. So now I can ask it the version, and I got 3.4.1. So back on the backup server, I'm going to create a new API token for this guy. So let's add one. We'll add one for lab user. We'll call this real server. And we'll need this, so let's remember it. Now over here on the real server, I'm going to save this in an environment variable. So PBS password is that. And I'll also need this guy too, lab user at PBS exclamation point real server. So I've got the username at the realm, exclamation point, the name of the API key, at, the domain name of the server, colon, the name of the repository. Okay, so I had to escape it for bash. And last one we need is the fingerprint. We know where to get that. We know how to copy it. So you don't have to set these via environment variables. You could set them on the command line. Typing your password on the command line is less secure, although I did just export on the command line as well. But generally you would put these environment variables in some sort of script that you would call periodically. So if you're interested, on my website I have systemd scripts. So if you're using a Linux distro that uses systemd, which is pretty much all of them, then you can just drop those in, add them a little bit to your liking, and have system level backups. So the most basic way to run this is to say Proxmox Backup Client, backup, and then tell it we want to backup root.pixar, which is our file name, and then that corresponds to the folder /. So there we go, so that was fast. So starting backup host real server, no previous manifest available, it skipped the mount point dev proc run sys, and backed up root. So now I have host real server, and that backup has root.pixar, and take a look at it, and there's my Linux system. So similar to container backups, this guy has the option for data or metadata. By default, it chooses data deduplication. I'll point you guys to the Proxmox Backup manuals. They're very thorough for how to use the client the rest of the way. But the client has a couple of other features I want to point out that you might like. So I'm here on the real server, and let's say I accidentally deleted some file and I want to bring it back. Now I could come over here and click on this and find the file that I lost. I don't know if it's in my home directory or something, and download it. But there's another way. So to start, I'm going to copy this name to the clipboard because this is the name of my backup. Host real server and then the date time. So we're going to do Proxmox Backup Client mount, and then I'm going to paste in the name of my backup, and then I want to recover from root.pixar, and we're going to send that to MNT. So now if I go into MNT, I have the entire contents of my backup mounted on the Linux system as a mount point. So while we don't have this neat trick for Windows servers, for Linux servers, the ability to mount your backup within the system is really helpful for recovery. So it's not doing this like in real time, it's not copying data. It's doing this with Fuse. So Proxmox Backup Client runs and it interacts with the server, creates a session with the server, and it can pull files out of that backup on demand as you access them on Linux, which is super cool. And for my last trick, live Ubuntu. So at least back in one of my previous jobs, I had to spend a lot of time imaging systems that couldn't run any sort of backup client. So we had to maintain a lot of very old systems for a wide variety of reasons. We had to support our software back 20 or 30 years. That meant running things that ran like Sun OS, Windows XP, that kind of thing. And some of them even ran relatively obscure real-time operating systems that can't run like a backup utility. So for all those systems, we had like a schedule where we would go pull the hard drive out, image it to an image, store that image, put the hard drive back in, and that's how we would back up those systems. So for this, I'm pretending that I got to back up that thing this way. So I'm booted into live Ubuntu here. I got a USB stick in the back, and I'm going to try to take a disk image of this system while it's not running. So I'm going to take this disk image, back it up to PBS, and store it there so I can do my periodical real physical system backups to PBS. So I also wrote a blog post on how to do this in the past, so I can just scroll down and copy my own instructions. So I booted into live Ubuntu, then I need to install the backup client, I need to add my username, password, fingerprint, and then I can do backup. Paste that in, yeah, whatever, paste. Let's see, so my own instructions tell me Proxmox Backup Client, backup, and then the image, colon, the path to the disk, and then backup ID, whatever I want to name it. So it looks like the live system's got a bunch of loop devices. SDA is my flash drive. So here I've got MMC block and NVMe ON1. So we're going to call that boot, and we're going to call that root. Okay, so it looks like it's working. And so over here I can see host bare metal. It's in the middle of working. If I click on tasks, I can see this guy is running, and it says he's adding a bunch of chunks, and they're all the same chunk, probably because it's whatever 0 compresses to. Okay, if you guys need to restore too, I've got the restore instructions as well, just in case you need those. So I think that pretty well covers the use of the backup client, whether you're using the client through Proxmox VE for your virtual machines and containers, or your bare metal or other Linux systems. Oh, one last thing. I mentioned earlier that Proxmox Backup doesn't have a sort of like local cache or distributed architecture like some other backup solutions use, but instead any backup server can push or pull to any other backup server. So let's set that up. I'm going to push from this guy to my production backup server in the closet. So coming here, my first thing I got to do is add a remote. So let's add a remote. We need the remote ID, which is just a local name. I'll call that Big Store. I need a username and password on the remote system. I need an IP address, and I need the fingerprint. Okay, so now the remote's added. I'm going to go over to Access Control. So here in Access Control, I'm going to go to Permissions. I'm going to add permissions to my lab user, who actually did the backups, to read for remote. So down here, I go to Path/remote. User is lab user, and the role for this guy will be remote sync push operator, or it could be remote operator if it's a pull type backup. But we're doing push backup, so remote sync push operator. So now I come over here to my backup, and I go to sync job, so we add a sync job. I'm going to do push sync today. So I'm syncing from local data store backup namespace root. Local user is going to be whoever took my backup, so lab user in this case. My remote is going to be the remote I picked. The data store is going to be backup. I have some namespaces here, so I'll add a namespace. And let's go. So now this guy is created. So I can hit run now, and there it goes. We found 4 backups to sync, and it's going to start doing that. Okay, so we synced the namespace, and it looks like it took us, I don't know, what is that, like a minute? Not bad. So now, on this server, in my namespace here, I have all of the backups I had on the new server on this one. So that's really all I got here for Proxmox Backup Server. So I've been using PBS now for about 2 years or so on my own. You can see my first server setup somewhere over here. That's the server I've been using this whole time. I've got tape backup, etc., and that's been great. Now, for those of you that are coming from a different backup system, I hope this has given you enough information that you can translate your experience from that system to PBS without feeling like PBS can't do the things you want it to do. Because like many times, when you move from one system or environment to another, things are named differently, some workflows are different, etc. And I hope you guys can make your Proxmox backup experience as good as your Proxmox VE experience. Now, big thanks to Ugreen for sponsoring this video with their NASing DXP 4800 Plus. This guy has been an absolute champ in this video. The included SSD was great to install PBS on. They support a wide range of drives within their operating system. You're welcome to use their operating system as well. You can run PBX in a Docker container if you want, for example, on Ugreen's NAS OS. You can even create a virtual machine, I guess, if you really wanted to, but that seems a bit overkill to me. Ugreen really wanted me to tell you that they don't restrict what drives you can use, unlike one of their competitors in particular that's been in the news recently. They even have a growing hardware compatibility list of drives that they know work with their operating system. I'm using Western Digital Red drives though. Those are really common NAS drives, and they should be supported by most NAS vendors except one, obviously. Also, don't forget about the Prime Summer Sale, up to 25% off, link in the description below. So thanks for coming along in this video. If you have any more questions about Proxmox Backup or Proxmox VE, the virtualization environment, feel free to jump into my Discord server, link down below for that. You can also find me on Mastodon. I have a Ko-fi as well. Ko-fi is kind of like a Patreon, but it's only like a one-time donation. I really appreciate those guys too as well. And as always, I'll see you guys on the next adventure.